at Google as a data analytics specialist to talk about all the new things happening at Google Cloud. Nitin, please give him a huge round of applause.
Almost 3 years, yes. I was at 2019 Google Cloud community event, very similar one. A lot of folks, a lot of energetic faces I can see today, and that too on a national holiday falling on a Sunday. So, first of all, thank you so much for everyone to come here. Definitely, I wish every one of you to have a great day, a lot of learning. Today we are going to learn more about what's going on at Google from terms of data cloud. I'll talk about some of the new entrants into our data portfolio and how you can make the best use of it. Okay, moving on. So since it's Gandhi Jayanti today, so let me remind you of one of the precious quotes of Gandhiji. Truth is by nature self-evident. As soon as you remove the cobwebs of ignorance that surround it shines clear. Now, many folks, and it's very common, truth is something equal to fact, right? That's what actually happens. And if you try to resonate this, try to draw similarities, data is very much the fact for you, the organization. It actually tells you what is actually going in a particular organization, be it from marketing standpoint, be it from financial standpoint, be it from the transactions that are happening. So data is the fact, or data is the truth. Okay? And if you try to organize it, if you try to remove the silos, it becomes self-evident and very clear. So that's one motto that I start with. Welcome all, I'm Nitin Khattar. I've been working at Google for more than 4 years, almost 4 years now. I've been working as a data analytics specialist, working with a lot of digital agents, helping them out day in, day out in adopting Google Cloud. I've spent many years in the past making these companies, but at heart I'm a data enthusiast, programmer for sure, but firm believer of team and team skills. So moving on, we'll start with how do you build a data future, okay, or a data culture in your company? What is the most important thing that everyone is looking at? Right at the center, innovation. Okay, how can I drive something which is different from what I have in my product portfolio? Okay, economic turmoil is going on, things are different. What makes me stand different from the others is the innovation. Now, how do you drive innovation? It's quite, those sounds simple that, okay, we want to innovate our product, we should bring new features. What should be driving those features? Okay? What important aspect that you would see and you would experience in all the applications or products that you use today, be it social media, be it e-commerce, they all are backed by limitless capabilities. Now, what those capabilities are? Data, workloads, and users. Okay? What I mean by that? A limitless capabilities around ingesting large volumes of data, understanding that data quickly enough so that those can be adopted into my product portfolio. Okay, these are the features I should be building. These are the things that I should drive my innovation towards. Limitless workload. Can I bring data from wherever possible? Can I do transformations? Can I do machine learning on the top of it? I should be able to try things as much as possible on my data. Data should not be sitting like a graveyard. Okay? And last but most important, the scale. The scale to the user, the reach aspect of it. How do you take your data to your data scientist? How do you take your data to your analyst? How do you take your data to each and every engineer which is out there, and not just be limited to certain data analysts who are responsible for creating some BI reports and just send it to your stakeholders? Like that's not what data should lead to. That what used to happen earlier, but that's not the case today. Okay, so we'll talk about what are the things that can help you drive some of the things, things in limitless data. So first, most important, the recent announcements and something that is now GA is what we have called Big Lake. So 4 years ago when I started the journey in Google Cloud, I was a hands-on developer and a lead back then. Didn't know much about Google Cloud, to be honest. Only one service that I've known about in the data ecosystem was BigQuery. Though BigQuery is still one of the most powerful services within Google Cloud, definitely, but there's a lot of things that have grown around BigQuery. Now, if you look at from this chart perspective, what I'm trying to say is that with BigQuery, there are already certain differentiators that it brings in from a serverless capabilities. So you have your read optimized storage, which is working on capacitor, something that helped from Parquet as one of the papers. So capacitor is a white paper, just go and read out that. Then we have a streaming engine, where you can very quickly do fast streaming inserts. But now the same thing with the help of a vectorized runtime and a BigLake API in the top of it now can be used for any data that sits outside of BigQuery. So, for example, let's say you Parquet or Arrow or JSON or semi-structured or sort of columnar data sitting in any of your open source connectors, okay? Or let's say it's there in GCS in an object repository form. I don't want to push that data into BigQuery. Have a data lake kind of a framework where some of the things mostly are in an object repository, and then certain things are in BigQuery or data warehouse. Now with BigLake, and with the help of Apache Arrow and the vectorized runtime that has been written on it, there is extremely powerful or extreme better performance when it comes to you are reading the data which sits in your object repositories. Now think of it, you don't have to push all your data into BigQuery, but at the same time, if you want to build an OLTP kind of a data lake, or let's say I want to keep my data organized in different lakehouse managed table APIs like Delta Lake or Iceberg, you can still do that with the BigQuery underlying. So BigLake, definitely I would encourage all of you to just go and take a read on it. Just try if you're already working with Delta or similar kind of formats. So BigLake is also one of the OLTP data formats that we have come up with, where at the same time you can create external tables of your data and join with any other dimensional data which is sitting within BigQuery itself with a very powerful and very low latency kind of a framework. Other important thing is recently come in order for you to bring in large amount of data. So when I talk about limitless capabilities, I should be able to bring in as much as data as possible with least transformation or least overhead in between, with maximum serverless capability that I can contribute to. So serverless replication to BigQuery with data stream, we recently announced that data stream is a CDC service or a data migration service. It used to initially, when it was released last year, till now, it was used to work in tandem with Dataflow, which is an Apache Beam framework. So there used to be a serverless data stream pushing logs into PubSub, and then there used to be a template of Dataflow used to run and push data into BigQuery. So it was a two-way mechanism of pushing data into your data warehouse. Now with data stream, within the preview, we have directly announced in a serverless fashion, you move your data from your CDC, your database sets, be it inside of GCP or outside of GCP. We support MySQL, Postgres is now review, Oracle, and this data can be directly pushed into BigQuery without the need of any pipelines. Another important aspect is, if you already been familiar with something called PubSub, which is very much on the likes of a messaging queue like Kafka in open source. Initially, if I need to bring my data which is coming in real time into my PubSub queues, I would have to build a Dataflow pipeline to push that data into BigQuery. Okay? Now that's no more needed. On PubSub, you can directly create something called a BigQuery subscription, which means your data, your consumers will be streaming your data directly into BigQuery with the help of BQ's streaming inserts and storage right API. So again, no need of any pipelines. If you're looking at ingesting large volumes of data, you can simply directly move it to BigQuery. Quickly moving on. From the log analytic capabilities. Now you have native JSON support in BigQuery, and one of the very important features that I've been following a lot is search. Now you can create search indexes and use this feature for any sort of a log analytics or any unique data. So initially, this was something that we used to always hear. Do we have primary keys? Do we have indexes in BigQuery? There's only limitation of partitioning and clustering. Now there's a lot more. You can go further and create search indexes or certain specific columns which can be used to identify certain unique data. Okay, like in case of log analytics, you try to pivot by a certain columns and identify, okay, where these particular logs are coming from, or what this corresponds to a particular user or a particular server, and that may not be the partitioning qualified. Now, there are other node features which are previewed, which have been recently added. I just want to take a note of it. Now, we don't have a limitation of queuing of concurrency to 100. Initially, that used to be the case, and used to simply send out an error. We have something called queues in BigQuery now, where you can have almost 2,000 of queries concurrently coming up, and they can all be queued, and the capacity using a fair scheduler will be allotted to that. Admin resource charts. This is a complete monitoring chart which was only available for reservation when you used to have reservations in BigQuery, but now this is available for on-demand as well, which can quickly help you look at job concurrency, slot utilization, and many other metrics. Table snapshots and clones. Snapshots have already been in GA, but clones have recently been added. Let's say I want to test my data before going into production, or let's say I have any sort of production issue that have come up, and I want to check this out on my production data without hampering it. I can take a clone, and it can behave like a simple, exactly like a table. I can query a clone, though I will not be able to do that for snapshots, right? Snapshots is more for backup and archiving processes. But for clones, you can simply create a mimic of your production data and start querying it the way you normally do a table. And column level data masking, this is more from a PII standpoint, where now I can tag a particular column, anonymize that particular data, and accordingly take action to the top of it. So now we talked about some of the features around the data aspect, and quickly talk about some of the features around workloads, how I can do the data integration aspects of it. I have the data in place, now I want to act upon that data, or let's say I will do some transformation of that. So the common tool that everyone is aware of is Spark, right? I think all of you know Spark, and it's all been there for more than 10 years now. Now, industry's first serverless Spark has been added by Google Cloud on their platform. It is very well integrated with systems like BigQuery, with Vortex AI. You can simply, with one click, trigger those Spark jobs. Do check it out. See, serverless, we normally think of, this is going to add a cost overhead. But if you try to compare this with the management overhead that you deal with in making sure your clusters are up and running, they are able to vertically auto scale, or let's say they're able to horizontally auto scale based on my load, it takes a lot of learning and makes a lot of learning and effort. If you want to go for a serverless capabilities, there's no harm in that. Do the benchmarking and compare the TCO with when you're running a managed workload versus a serverless workload. Now, another aspect of it is something called Dataflow Prime. So Dataflow has been there for quite some time. It's been 4 or 5 years. Apache being top Apache projects. But now with Dataflow Prime, we have enabled vertical auto scaling in your data pipelines. So initially it used to be like, okay, everyone used to just come up and say, okay, big data, distributed programming, let me just do horizontal auto scaling. Okay. But the problems with the horizontal auto scaling also comes in. You're not able to identify what should be my memory or my CPU requirements for a particular worker. You cannot always divide work into too many parts. Every part also requires some sort of a memory. So there is a profiling that needs to be done, and then you identify, okay, one worker or one machine should be like this. But still, after a certain point, your scale goes up, and then again it breaks. Because though you are doing the horizontal partitioning or horizontal scaling, but your one unit may not be enough to take that particular step into memory. So that's where the vertical auto scaling comes in, where not just from a horizontal standpoint, it automatically scales up vertically and scales down as per the needs of your pipeline. And this works for both batches for you. Now, next important thing is around Dataplex. Now, this is again a new service. So, 4 years back, only BigQuery and some surrounding Dataflow and others. And now, if you look at, now you have Data Stream, which can bring in data in a serverless fashion. You have Dataplex, which gives you an enterprise-wide governance. You can bring your, you create a data mesh kind of an architecture with the new terms like data fabric or data mesh. Ultimately, you can create multiple lakes and zones where you can have different functional data within your organization. and have a stricter governance and metadata management. Okay, so lastly, the reach aspect of it, how different users within an organization can benefit from the limitless capabilities of your data. We talked about how to ingest large scales of data. We talked about how you can run many different workloads and transformations on that data. Now it's time, how does it take care of needs of each and every user? So the first thing that you would have commonly in many organizations nowadays is data scientists. Okay, though I would still, think that way that it's ML is not something which is limited to data scientists. It can be easily done by folks or data analysts or programmers, because ultimately, everyone is not a researcher or scientist who is inventing an algorithm, right? You just need to apply it and you need to apply it in the right manner. So with the Vertex AI workbench, what we're trying to offer is that you have a unified data fabric or a layer 2 dataplex. You in fact have a data mix where you can do analytics and Spark and do ML on Vertex AI. But for all the end-to-end orchestration, okay, or a complete workbench where you can integrate with any of the underlying tools. I give you a Jupyter managed notebook environment where you can have your notebooks, your user managed or self-managed notebooks. You already have a lot of runtimes available, and you can easily connect to different underlying or data sources or data repositories. So this gives you one single workbench where you can simply go and work either from a data science or from programming perspective or from data engineering perspective. Another important aspect that we brought into, everyone used to come and ask me, when should I use Data Studio? When should I go for Looker for all my BI whatever use cases? And they always used to come, okay, Looker is chargeable, Data Studio is free, but Data Studio does not have governance in there. Data Studio is something not properly managed by Google Cloud. So this year, Q2, I remember April 6th, this was announced that Google Data Studio is not now part of the Google Cloud portfolio, and this has now been integrated with Looker. So think of it, the Google Data Studio, which already has a lot of 200 plus community connectors, but what it lacks is the governance and the semantic modeling. With the Looker integration, if you already have Looker in your organization, if you already are dividing semantic modelings or doing row or column level security and governance out there, the same can be extended over to Data Studio. So Data Studio becomes your first landing kind of a BI tool. When you need more governance, you don't have to shift yourself into a second tool, but use the best of the Looker and put on top of Data Studio. Lastly, BI engine, there are a lot of capabilities from a caching perspective, vectorized runtime, how you can easily, it does not caches your query results, but more the data underlies in the query, big query, and reducing the latency. So subsettings, an important feature that has been added within BI engine is preferred tables. I need not to enable BI engine for my entire project. I can choose which particular dashboard being served by specific tables only to be enabled by BI engine. So I can selectively choose that where I need to put my accelerator of BI engine and where not to put accelerator. So these were some of the features that I wanted to talk about that have recently come in the last 3 or 6 months that have actually tried to make the data ecosystem and adoption of Google Cloud much more seamless, at the same time much more varied overall the variety in terms of the open source, in terms of the data lake, and we need large volumes of data. So a lot of capabilities have been added on that, and even the roadmap that is going forward. A lot of things are there on DQML from Vertex AI perspective. What we're trying to make is a sort of a data ecosystem where we are coming from any particular background, or let's say you are good in certain tool, your company has already invested in certain technology, they can be easily integrated with your data ecosystem. So sign up for BigQuery, there are a lot of industry solutions out there. Look out for Data Cloud out there on Google Cloud. And with that, I take your leave. All the very best. Make the best use of the day-to-day. And if in case you have any questions, just feel free to reach out.
How we can minimize the risk when we entirely modernize the data using the new techniques and the kind of operating systems and different others and all together eventually growing. How can we reduce the risk?
I think that's a very important question, because we normally keep the risk aside when we are working with data or any other technologies. What I normally suggest customers is that try to look at and backtrack from your use cases, okay? Because that's an important area where you know where your business is going to put their money, okay? So from those use cases, you are easily able to backtrack and look at, okay, these are the data I need in my data. So you don't go by the traditional approach, bring my all data into a data lake and then I will decide what I can do of it. That's a very bad approach, I would say, and that's puts you in a lot of risk. So you backtrack from the use cases that you have, try to make sure that the data is in compliance, is properly encrypted, and things are, the access controls are very much in place. But this can only happen, over allocation as you go from one use case to another.
Don't you think that if we kind of backtrack and we have to soil our hands, so rather than expanding and thinking of expansion plans, we are going backwards just to modernize this in a very efficient manner. And still, when it is the data stream that is in the picture, we are getting a lot of bot traffic as well. How to minimize that as well? Because the entire organizations, they are highly perplexed now because they are getting all the data that is cluttered and they are going backtrack. So please comment on this.
You're completely right in that. See, there is absolutely enormous amount of data that we deal with in any organization today. The logs that we used to just throw away, now they have become precious. So first, very important, again I would say, finalize your top 3 or 5 use cases first of all in your organization. Okay? That you combine. Try to identify what different data sources, entire pipeline that you have from the source to your destination. Map it, not just from a data source perspective, but from the power users who are going to use them, how they are going to use them. And as you said, as the traffic is increasing, there's a lot of new data coming in. See, ultimately, there's going to be a point where we need to organize things. I can go with my business priorities and say that I can get me a report done in day. But if my data platform is not sorted out, that report might lack certain facts which I am not collecting. So it's a partial effect, right? So again, I'm trying to say is that don't over engineering, you bring everything together and then think of it. No, you should be aligned to business, backtrack from what the priorities they have, identify the top 3 or 5, and accordingly give them, the business, a complete transparent view that, okay, from these sources, these data I need, this is in this form, these are transformations I want to do on it, these are the different users, they need this data in what particular form, are they data scientists or analysts, or are they any programmers, they need data in a Jupyter kind of environment, or they need as an API. Try to identify what are the interfaces between each and every stage and how you can minimize the risk and any sort of data exfiltration chances in those interface areas, which will give your business a kind of a confidence that yes, we're trying to move towards something which is more specific to our priorities, but at the same time making sure that those important facts are being collected and there is no chances of any sort of exfiltration or any frauds out there.
Thanks, Mr. Shan.
So my question is around Vertex AI. I am in data science. So the question is like when we use Vertex AI, so when we write the data, so it is going to be in the runtime of the cluster or it is going to be in the permanent?
Sorry, you mean to say runtime of the cluster, which means?
Like when we are running the cluster for the notebook, just like in AWS or on the database. So when we run the cluster, the data in the AWS goes to the runtime.
Yeah.
So is it same for the Vertex AI?
Yes, to a larger extent, because that's how you notebook. So there's nothing new in terms of the underlying technology. It's the same Jupyter notebooks, right? But it's more like a horizontal scalable, it's managed in terms of and taking care of the nodes. But this is a common phenomena when you deal with notebooks. You bring in the data in the runtime itself, in the memory. But with Google Cloud, you try to add more sort of automation out there where data gets persisted to Google Cloud. So anything that you do on your notebooks, there's a temporary directory which is associated where the data gets kind of done. I'm not sure the database also will have that feature where you can have local sync with your data. And you can also change runtimes and create environments. And those environments can be added to your current notebook. So previously it used to be like a sort of a coupled environment. Now it's more decoupled. You have a runtime separately, you have your notebook programming separately, and you have your data separate. Now all three of them can be plugged with each other. So it's more of a plug and play kind of thing. But data would remain, at least when it is getting crunched, it's going to be there in the memory of your cluster.
So, personally, I feel like when I use Databricks, there is one problem in that. Like when the data, I write the data in the runtime, I can't access with the terminal. Like the terminal of the Databricks directly connected to the DBFS of the Databricks on which the data is passing. So this problem also exists in Vertex AI because at there I can't change the terminal to that drive which is working runtime because it is like a memory which is randomly selected. So there is no drive exists like in which the data is getting stored.
So with Workbench, we have tried to solve that problem. I know, it's bind to a particular node, and that's why you're not able to switch and share the data. So we can discuss separately outside of this, but with the Workbench, we have tried to unify your cluster in a way that your Cloud Shell or the terminal that is attached to it that shares your memory runtimes of the other nodes as well. So we're trying to fix that problem, but I'm not sure whether it completely solves what you are specifically looking